For this anatomy chapter, we are in chapter 9 in your anatomy book, page 218, which is the muscular system. So let's get going. So we've already done the skeletal system for this module. And so, of course, the skeletal system gives us the framework that we hang our muscles on. And that's great, and that's the first kind of muscle we're going to talk about, the skeletal muscles. But we have other muscles in our body that are not attached to our skeleton, so you will see the difference here in just a little bit. So first I want to talk about the look of muscles. And there's our three kinds of muscles we have in our body. We have the skeletal muscles, we have the cardiac muscles, and then we have the smooth muscle. And so if you look at those three pictures, there are definitely some differences in how they look. Both skeletal and muscular have those stripes in them, and those stripes are called the striations. And then the smooth muscle does not have those stripes or those striations. Okay, so 2 of 3 have striations. Great test question, right? Which one has it, which one doesn't? You should know that. Okay. And obviously those are the 3 kinds of muscles, skeletal, cardiac, and smooth. Okay. So starting with the skeletal muscle is also known as voluntary because those are the ones that we move by choice. I decide to pick my hand up and the muscles that are connected to my arm come up and they make that motion happen. Okay, I need to swat a fly away, or I need to scratch my ankle. All of those are our muscles attached to our skeleton, our bones, that we are choosing to make a movement. So that's your voluntary muscle. Okay, and then of course it's striated. It says there that we already talked about. The next kind is your cardiac muscle. Cardiac muscle is found in the heart, just like the name implies. The heart is not voluntary. You and I do not think about our heart and say, heart, pump faster, pump slower. We don't control that. We have no conscious control over that. So it is an involuntary muscle. And with the cardiac muscle, we have this structure called intercalated disc. Let me scroll back up. And an intercalated disc is showing here in this picture, and it's almost like a little stitch holding different muscle fibers together. And you can see one here, but you can see them everywhere that it's pointed there for those intercalated discs. And it looks like a little stitch holding them together. And that's exactly what intercalated disc is. It's where the muscle fibers are coming together and being held together to the next one. Smooth muscle, again, is not voluntary. You and I do not think about these muscles and say function. They are also called non-striated because they're the ones who do not have those stripes. And another name for the smooth muscle is our visceral muscle. In med term, viscero means organ. So this is our organ muscle. This is the muscle found in our stomach, in the intestines, in the bladder. All of our organs have some muscle in it. Again, we do not control. So when our body decides we need to urinate, those muscles contract or relax based on unconscious commands from our brain, but you and I do not think about it. Okay. So now we know which ones are voluntary, which ones aren't, which ones have striations, which ones don't, which ones, what the 3 names are. I could think of probably 10 different test questions on just the small amount that we've covered so far. So how does a muscle work? A muscle has to be attached to the skeletal muscle anyway. The skeletal muscle is attached to a part of our skeleton at each end. And so we can see it's attached here and it's attached here. And it's a tendon that actually attaches the muscle to the bone. And those attachments are going to pull or relax depending on if we want that muscle to contract or to relax. And so the muscle, as it's connected, I'm going to actually make that webcam a little smaller. There we go. As that tendon is attached to the stationary bone, it's called the origin. And the bone that's going to actually move is called the insertion. So when we decide, using that picture, we decide I'm holding that ball like the picture, and I decide I want to bring it up, the muscle attached to my lower arm is going to contract and it's going to pull that up. And if I want to extend it back out, it's going to relax and let that muscle go back out. Okay. Each skeletal muscle is made up of myofilaments, and there are thick and thin ones, and the thin myofilament is called actin, and the thick ones are called myosin. Okay. And those are the filaments that create that muscle tissue. Okay, there's thick and thin in there. And it actually takes a lot of protein, which we'll talk about later, about protein that control the muscles or help us build muscle cells, those things. Okay. We also have a sarcomere, and the sarcomere is the functional unit of the skeletal muscle. And it is made up of those myofilaments, the thick and the thin, the actin and the myosin. And when you look at it under a microscope, you see these Z lines. And the Z lines work a lot like the intercalated discs do in the heart muscle. And it's just where the different muscle tissues are coming together. And that Z line is where it's holding it together. Okay, we already talked about that. Okay. Functions of the skeletal muscle. So when we did skin, we talked about the functions of the skin, we talked about the functions of the bone, and so now we're talking about the functions of skeletal muscle. Of course, number one, it gives us movement. Those skeletal muscles allow us to move and get up and walk across the room, or do somersaults, or ride a bike, or whatever it is you want to do. And the muscles, when we get into them, no muscle does a movement on its own. Any action that you want to do, there is a prime or a primary muscle that is intended to create that movement, and that's the prime mover. So if I decide I want to flex my hand, there are certain muscles that is the primary muscle that's going to make that happen. However, no muscle works on its own. The helper muscles are called synergist. And so those are the ones that work with the prime mover to accomplish that motion. In addition, we have muscles that are intended to do the opposite motion. So just like I have muscles that'll bring my fingers down, I have muscles that'll bring the fingers back up again. Okay? So they work in opposite order from each other. And so when I need to put my hand down, my fingers down, the muscles that put them back up have to relax. They can't be contracting at the same time as the ones coming down. Otherwise, I won't get any movement. And so the antagonists are the opposite muscles, and those have to relax to bring it down. And then when I want to bring my fingers back up, the ones that did the first action have to relax, and now different prime movers are going to make my fingers come back up. Okay, so they have to work in conjunction and be very smooth motions. We're going to talk later about different diseases like muscular dystrophy, where the motion is not smooth because of a disease causing an impairment to this process. Okay. The next function is posture. You might think you're not using your muscles too much, but just sitting in a chair takes some muscle tone so that you don't fall over. Okay, so you have enough contraction going on in those spinal muscles so that you don't tip over. And if you don't believe that, take a baby who has not yet learned to sit up, and you sit them up, what happens when you let go of them? They just plop right over because they have no muscle tone built up in those muscles to keep them upright. And so we have enough contracting going on in our spine to keep us upright, to keep your head from not flopping over like a newborn baby does. Okay. Heat production. When our body has sensed that we have gotten cold, of course we have sensors in our skin and they communicate to the brain that, hey, I'm cold. One of the reactions through that negative feedback loop is that we can shiver. And shivers is moving our muscles to create and generate heat. And so heat production is done by muscles. And then the last thing I want to talk about is fatigue. If we use the muscles repeatedly without enough rest, we will fatigue our muscles. And at some point, you could run them out of movement. Now, it takes an awful lot to get to that point. But we've all had a very busy day before where we've walked a lot. Maybe we went to an amusement park like Disney World. I live in Michigan, so Cedar Point is like our place to go. That maybe by the end of the day, after you've been walking for 12, 14 hours, that you are just exhausted and you are barely being able to pick up your feet to get back to your car at the end of the day. And we have fatigued our muscles. Now, we haven't gotten to the point where we are going to freeze in our steps and not be able to move, but it is possible, okay? And we'll talk later. Well, I talk about it here. We're going to talk about ATP later on, about the ATP, adenosine triphosphate, something like that. Is what gives our energy muscles, or our muscles the energy. It uses oxygen, things like that. We can get to the point where we have forced our muscles beyond the oxygen that it has, and we've created an oxygen debt to our muscles. Now, your muscles will keep moving, but at some point, you may have some adverse reactions to that oxygen debt because we've created all this lactic acid buildup in our muscles. If you are not accustomed to exercising and you go to some kind of an aerobics class, Zumba, or one of the biking classes that are really popular, things like that, or you just go work out at Planet Fitness, and you are sore the next day, that is oxygen debt. That is a buildup of lactic acid. Now, we can condition our body to work out more if that's something you want to do. My doctor, when he was much younger, used to run, and he'd run 10, 15 miles. And I said to him, God, how did you do that? How did you get to the point where you could run 10 miles? And he said, I started by running to the mailbox. And when I could run to the mailbox without killing myself, then I ran to the stop sign at the end of the road. And then I just kept increasing my distance. And so someone who wants to be a runner, someone who wants to run marathons, you don't start out by running 10 miles. You start out by running to the mailbox. And you can teach your body to do those things, and you will condition your body, and there will actually be some physiological changes so that you can do those things. Okay. If you have already done the nervous system module, which of course was just last mod, so if you're a freshman, you have not, but everybody else has. We learned about the brain, and this shouldn't be a new term to you, this motor neuron, or this neuromuscular junction. These shouldn't be new terms to you. But before the muscle can actually move, the brain has to tell it to move, okay? So if I make the conscious decision to scratch my nose, oh, I have an itch, I need to scratch my nose, my brain has to talk to my finger to say, scratch the nose, okay? And so it starts with a nerve impulse, and then the nerve has to communicate to the muscle, and that's the neuromuscular junction. It's where the neurons and the muscles come together. Remember, a junction is any connection of two things. And the motor neuron, the neuron is the communicator, tells the muscle what to do, whether it's to scratch your nose, scratch your ankle, get up and walk across the room, whatever it is. It all starts with the brain deciding it needs to happen and sending out that message. All right, there are different kinds of muscle contractions. We have twitch, tetanic, isotonic, and isometric. Twitch and tetanic are the less common of them. Twitch is a quick, jerky response. And so this is not a normal movement. Like someone might say, hey, my eye is twitching. It's usually unconscious. It's just happening because the muscle somehow is being stimulated with a nervous impulse. It's not a conscious movement. Tetanic is a little bit more, but it's still not an actual conscious movement. Isotonic and isometric are the two types of movements that we do on a daily basis. Isotonic, what is happening is the muscle changes length, okay, but the tension inside the muscle stays the same, but it changes length. And this is the kind of movement with any action movement you can think of. Picking up the ball, like in the picture there, jogging, riding a bike, walking across the room, or just lifting your hand up. Okay, those are all isotonic movements. So anything that actually you think about your body actually moving, doing something, that is isotonic. The other kind is called isometric. It has the opposite definition. The muscle is the same length, but the tension inside changes. With this one, you are not actually moving your body. You are contracting the muscle, but you're not moving the body. So, imagine you are in front of a barbell that has about 600 pounds on it. And I say, pick it up. And you reach down and you're holding the barbell and you're pulling with all your might, but you can't move the barbell. That is an isometric movement. So the muscle itself is not moving, but you are flexing it inside, which changes the tension inside the muscle, but the movement of the muscle is not happening. Effects of exercise. When we think of exercise, there's two kinds of working out that somebody could choose to do. The first kind of working out is considered to be strength training, and this is like what a bodybuilder goes through. So if I go up to a barbell that maybe weighs 100 pounds, some of you can probably pick that up, I cannot, and I go to try to pick up that barbell, I probably can't do it. But I could probably teach my body to do it through strength training. I can pick up smaller barbells, do different workouts with weights, and eventually be able to pick up heavier weights. Okay, that's one kind of working out. The other one is endurance training, which increases your aerobic ability, and this is the runner. I don't run, so I start by running to the mailbox, and then I run to the corner, and then I keep going. I have a girlfriend who runs on a treadmill, and she tells me all the time that treadmill running and outdoor running are two different things. But she runs on a treadmill every day. She does, well, she used to do 5 miles, and not that long ago, she upped it to 6 miles, and then she just put on Facebook the other day that she decided to do 6.5 the other day, just because she felt like she could. Well, what she's done is aerobics or endurance training. Once your body gets used to a certain thing, now you can handle more. And that's where she keeps adding on miles. A couple of years ago, I was really into Zumba. I could do an hour Zumba without even barely being out of breath. Yeah, I sweat, but I was barely out of breath. And I got to the point where I could actually do 2 hours Zumba in a row and be fine. If I did that today because I have stopped doing it, my body lost its training, I would be back to almost dead at the end of the first hour. But if I wanted to get back to that point, I could certainly do it, as well could any of you, unless you have other physical limitations. The other two terms in here, disuse, atrophy, and hypertrophy. So med term, trophy means growth or development. So med term A for atrophy means without. So it means without growth or development. And we put the word disuse in front of it. So long-term not using your muscles creates the muscle to waste away. And you can see this with somebody who is a quadriplegic and can no longer use their leg muscles. That's part of some of their physical therapy. Could be someone else exercising those muscles for them. And then hypertrophy, hyper is med term for excessive, so excessive growth and development. Hypertrophy is that bodybuilder who's got these big defined muscles because they have built up the muscles in those areas. All right, we're going to stop video 1 here, so come on back and we'll pick right up here with video 2.